Okay, in this video, we're going to talk a little bit more about angles. First of all, non-uniqueness of angle measure. Now, what does that mean? Let's say I draw this line here. This black line represents a certain value of angle for this line. But then the red line also represents an angle for the same line. So which is it? For example, I could say this is 30 degrees, or I could say it is 390 degrees. So essentially what is happening is any point can be reached by a simple rotation. It can also be reached by a larger rotation, and it can also be reached by a rotation that is larger than that, and it goes on, right? Now, this is a consequence of the fact that after one rotation, one full rotation, the angle values are repeated. Right, which means that 30 degrees is essentially the same as 390 degrees, essentially the same as 750 degrees, and so on. So for the purpose of unique values, what we do is we call these principal values, okay, and we say that it's between 0 degrees and 360 degrees, or between 0 radians and between 2 pi radians. So if it is not, then you reduce it by subtracting multiples of 360 degrees. What does that mean? For example, if I say the angle is 470 degrees, what you're going to do is you're going to think of the nearest multiple of 360 is 360. So this is 470 minus 360, so it's 110 degrees. Similarly, if I say 7 pi radian, the nearest multiple of 2 pi is actually 6 pi. So this is minus 6 pi, and it's the same as pi radian. Now a tricky part. What about negative angle? Negative 50 degrees. Now if you think about it, we define moving counterclockwise as positive. So moving clockwise would be negative. So negative 50 degree means you start moving down here. So in order to have a positive angle, you're going to need to find this. But the full circle is 360, so this is going to be 360 minus 50, which is 310 degrees. So negative angle can also be written in the principal way, which is between 0 and 360 degrees. You just have to add 360. Or if you don't want to remember the rule, which really, it becomes obvious if you draw it, right? So for example, negative 120 degrees. Negative 120 degrees puts me in third quadrant. So this is 120, which means the actual angle here is going to be 360 minus 120, which is 240 degrees. So this makes sure that we are talking about unique values by ensuring that whatever the angle is, we are able to bring it down to be between 0 and 360 degrees. Okay. Now with that setup, let's look at how we can find these trig ratios for any given angle. Okay, for example, cosine of 71 degrees. It's 0.945. So 0.945. 0.945. Cosine of 112 degrees, negative 0.375. Sine of 157, 0.375. 391, tangent of 217, 0.753, and tangent of 711, negative 0.158. Now here 711 degrees is not between 0 and 360, so I'm going to subtract 360 and see what I get, which is 351 degrees, and I'm going to plug in to find tangent of 351, and it should come out to be the same, and it does. So see over here, these values match up. So when using the calculator, you don't necessarily have to convert it to principal values, but as we go along and we learn about inverse trigs as well as other ideas, you need to be aware of the fact that the values repeat. So in general, we always want to report the principal values. Now one thing here is we have a bunch of negative numbers, which is kind of strange when you think about in terms of triangles, because so far in the day one videos we saw that these trigonometric ratios arise out of ratios of lengths of sides of triangle, and lengths cannot be negative. So what's going on here? Now what is happening here is a very standard thing in mathematics, is where you define something based on an obvious characteristic. Like we define the 6 ratios, trigonometric ratios, based on a right angle triangle. But then it turns out that it also has an existence in terms of circles, and that is why we are able to convert it into a function. So let's see what happens here. Again, recall these are called quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now let's say I have a point P in quadrant 1. That is the x value, and that's going to be the y value, right? Now this is positive and this is positive, which means that if this is my angles theta, if I look at the ratio sine theta, let's say I'm in quadrant 1, cosine theta, tangent theta, opposite is positive, hypotenuse is always positive, so that's going to be positive. Same with cosine and same with tangent, which means in quadrant 1 all of these ratios are positive. Now if I were to go into quadrant 2, then this x value here is negative and the y value is still positive. Now sine is opposite, which is positive over positive, so that's still positive. Cosine is negative over positive because adjacent, the x value is negative, right? This is the negative x-axis. So cosine is now going to have negative values. Similarly, tangent is positive over negative, which is negative. Now this means that in different quadrants, the ratios have different type of values. They may be positive and they may be negative. Now I want you to complete this analysis for quadrant 3 and quadrant 4. When you complete this analysis, you are going to have this rule, which can be remembered by this acronym ASTC, which means in quadrant 1 all things are positive, all ratios are positive. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. And a mnemonic for remembering this is all students take calculus, ASTC, and you go counterclockwise just like the measurement of angles. Now, a consequence of this is that trigonometric ratios are very much related to real numbers, because we see that we can plug in any angle into those functions, right? So let's say I take a circle of radius 1, so this length here is 1. I take any point P on the circle. The coordinate of those points are x and y, and what that really means is this side of the triangle is x and this side of the triangle is y. So sine theta by definition is opposite y over 1, which is y, and cosine theta is x over 1, which is x. Now this is really nice, because what it tells me is that any point in the circle can be just represented as cosine theta comma sine theta. Now recall the equation of circle from Math 103. The simplest one is x squared plus y squared equals 1. So if you plug in there, it follows that cosine squared theta plus sine squared theta is 1. And this is a very important trig identity. We're going to be talking about it again later in the course, and we will be using this a lot, and you'll be using this very often when you do calculus and integration, finding areas and volumes of figures. So it's an important identity. You can verify them for these values. Now, while you verify it for this radian, I'll show you how to change your mode into radian. So right now it's selected on degrees, so I change it over to radian. Okay, now change it over to radian. I'm going to find cosine pi over 7 and sine pi over 7 roughly. So cosine, now for pi, don't use 3.14, use this pi button on the calculator. So pi divided by 7 gives me roughly 0.9, and sine of pi divided by 7 gives me roughly 0.434. Let's make this 901. So if I'm to evaluate cosine squared plus sine squared, I'm going to type in the squares of these numbers. So 0.901, this symbol here is for squaring, plus 0.434 squared. I press enter and it comes out to almost 1. Alright. Now the reason it's not exactly 1 is because we rounded off some values. So if instead you typed out, say, sine pi over 7 squared, not sure about the order here, one second. Yeah, I think that'll work. Sine pi over 7 squared plus cosine pi over 7 squared is 1. So instead of rounding off, if you use the values, it's going to give you 1. Now you can try the same with 60 degrees, but make sure that because this is now in degrees, you need to go into mode and you need to change it to degrees instead of radians. That's the end of this video. We'll talk about some identities in the next one.